Hello friends, welcome to my channel. So today we are going to talk about ARP, which is the protocol which used to do IP to MAC resolution. So we are going to see what is ARP and how does it work, how can we configure, how do we see ARP works when a device try to reach other device in a network. Okay, so this we can see using a tool called Cisco Packet Tracer tool. And we are going to build a basic topology to see how ARP works. Let's get into the topic. So this is my packet tracer tool where I'm going to build a network. Let's say I'm going to take one server, and then let's go to take one switch to connect my end users. Let's say I have some 3 users. 11, 12, 13. So let me connect them all together first. Switch to the server and then to rest of the devices from the switch. So let's assign IP address to all of them quickly. 1.1.1.1. This PC can be 1.1.2. This PC can be 1.1.3. And let's have the server IP address as 1.1.4. So all are in the same subnet. So we are going to just see basically how an ARP works in this network. So as I told, ARP is an address resolution protocol which is IP to MAC resolution. That means, in other words, say you have an IP address with you, but you don't know the MAC address of the other device connected to the other end of your device. So for communication between two devices, you need a MAC address which is associated with your data link layer, so that you will form a packet and just send it across the link to reach the other end device. Say PC 11 wants to connect to server, so it needs to know what is the server MAC address. Then only it will get a full-fledged packet. Because for building a packet, you need a source IP, destination IP, source MAC, and destination IP. These four basic parameters should be there in the packet, so that we can achieve end-to-end communication between this PC level and server. So as we assigned an IP address, here is 1.1.1.1, and this server has been assigned with an IP address 1.1.4. So we know both source and destination IP address. If you take a MAC address, we know this MAC address because this is the source. So if you go to PC and if you give ARP-A, there is no entry. So as I told, ARP is the IP resolution, IP to MAC resolution protocol. So naturally they will save those information in the table called ARP table. So right now the PC does not have a ARP table entries here because this is the initial state of the network where we just connected the network, built this network, and we haven't initiated any ping or any connectivity or any reachability options we have tried to build an ARP table on each devices. And of course, if you take this network, each device will maintain its own ARP table, which is the mapping between their IP address and the MAC address. So right now the ARP table is empty, as I said. So let's say we are going to ping 1.1.1.4. Before that, let's go to the simulation mode and then try to ping. So you can see here 2 packet has been built. One is the ICMP, another one is ARP packet. So if you go to ICMP packet, you know this is the ICMP packet which is built for ping request. So you can see source IP, the PC IP, destination IP. Okay. And similarly, if you go to our ARP packet, you can see the source IP, you can see the destination IP, you can see the source MAC, which is the PC's MAC, whereas the destination MAC, the PC does not know the destination MAC. That is why it is generated this ARP packet when you initiate a ping. So initially it will put 000 as the MAC address table, since MAC address, destination MAC address, since it does not know the MAC address, and sends the packet. So the moment it reaches your PC, it reaches your next device, it will forward to all the ports, because the switch will broadcast the unknown frames when it receives. So it will broadcast to all the frames. That's what's going to happen. So switch will go to the switch is sending packet to all, forwarding that packet to all the ports except the received port, and this will reply back to the switch stating that I have this destination MAC address and my destination IP address, and my MAC is this. So now you can see the ARP. If you see, the switch is sending a packet, and you can see the flow here. So the server is send a packet again back to the server, one is sending back to the switch through ICMP reply. Everything has happened. So now let's see whether you are able to see the ARP entry. See here, it's been achieved now. ARP-E. So what happened exactly is, now the ARP table is being formed here, and you can see the IP address 1.1.4, which is our destination IP, and the corresponding MAC has been populated in the ARP table using the ARP resolution protocol. So if you want to validate it, just go to the server and then just go to physical. This, you can see the MAC address of this server, and you cross verify the PC. So this is the MAC. You can see 000D BDDA 50A5, 000D BDDA 50A5. So this is a MAC that we have received. So now that's why we are able to achieve ping.1.1.4. So we are able to reach it. Since it's in a simulation mode, it's stopping it. So now you can see it's pinging. So this is how an ARP resolution happens on each device. This happens in all the devices initially, and they will maintain the ARP table once they resolve the IP to MAC. So this is how ARP works across the network. I hope this video is useful to you. Thanks for listening.